In the problem 2, we estimate the activity duration. And in a project, we have multiple hundreds, thousand, 10,000 of activity, and I show you a real project in the previous lesson videos. So the question becomes how to determine the sequence or the order or the relationship between those activities. So if that's the next step, and step 3, we establish the sequence relationship among activities or the tasks, very important step. So that the focus of problem 3 to demonstrate how to establish the relationship. So let's go to problem 3. Develop a relationship to build a pier as shown in the following figure. So if you go to Naples Piers or Fort Myers Beach Piers, you see something like that. Of course, they have more sophisticated, just like handrail, etc. To simplify, we have a portion of the pier that includes 6 piles, 1, 2, 3, 4, 5, 6, and then we have a headers, 1, 2, 3, and then we have the deck slab, 1, 2 on top of that, right? And of course, deck slab 3 if we have another pile and another header continues, and that depends on the length of the pier. We need to add more in there. So to develop and install this pier, what should be the sequence? And of course, I give this because that is intuitive. You can be able to figure it out without this problem. But I want to show that so that you can apply in a more complicated problems that you can apply in the project 2 to determine the relationship between the activities. So let's go to the slide again so that you can see the finger here, and then I break that out into one portion of the piers, which include 6 piles, P1 to P6, and then the headers, we have 3 headers, H1, S2, S3, and then we have a deck slab, DS1 and DS2. To make life easy, I'm going to put the S1 and S2 for the deck slab. So as you can see, to do this without learning this class, the order should be, I need to do the bottom first, which means I need to complete the pile, and then I install the headers, and then I do the deck slabs. And that we call it physical structure order. So what we need to do to finish P1 and P2 here, P1 and P2, and then you go to put the H number 1 in, and similarly we continue with the P3 and P4, and then we put H2 on top of that, and then at the end you can put the deck slab, and then that will finish the first module. So that we call physical structure order, and that in 3D. Now let me show that in 2D how it look like. It look like this. So first we finish P1, P2, then I can put the H1 in, and then I cannot put H1 deck slab. I need to finish header 2. To finish header 2, I need to install the pi 3 and pi 4, and then I put header 2, and then when we have header 2 and header 1, we can put the deck slab number 1, S1, the red one you see. And when we continue to do the pi number 5, number 6, put header 3, and then we can put S3. So that is a sequence, and we call it that is physical structural orders. And now look at the detail, and you can see for P1, the pile itself, we have 6 piles, and this 6 piles, you only have 1 machine to do. You don't need to do 6 machine, pile in a driver and install all 6 piles at one time. you need to do in sequence. And what should be the sequence for this? And there are multiple sequence. When I give you one example in two example in this case, that how to do the piling, the sequence, and of course, like I said, you can put multiple sequence. And let's go back to the slide here. What are the sequence? Because P1, P2, P3, P4 are separate location. So what we do, we can do at any orders. But to put that in the good sequence, then the properly what we do is, let me finish P1 first, go first, and then I go to P2. So I move machine, go to P2, and go to P2. Then I go to do P4. You don't want to jump to P6 because that is the distant farther. You don't want to move back and forth. So in that case, and then when after P4, I can jump with the next pipe that I do is P3, and then the next is will be P5, and then the last one it will be P6. And that sequence we call that here alternate row pile driving. Alternate, and you can see just one row P1, P3, and P5 in one row, P2, P4, and P6 another row. I do alternate. 1, jump to 2, and then 4, 3, 5, 6. That alternate row piling. The other, why we need to jump between the row? The other option, it can be like this. Let me do the sequential row piling. From P1, I go to P3, that number 2. And then let me finish this row first. Go to number 5. Finish that in the third. And then I go back to number 2. That is pile number 4 to complete. And then complete the second row. That will be 5 for P4. And then go to P6. It will be the last one. And that we call sequential row pile driving. So as you can see, yeah, two ways that you can do at least. Of course, you can have multiple, but that sound like efficient because we don't have to move the rig, the driver, pile driving too much. So with that one, we can show that in 2D in here. I have to show that to you. So the first one is alternate row pile driving that I just showed you. So I can say from P1, I can move to P2, and then I go to P4, and then I alternate to change its row, and then I move to P5, and I finish at P6. So that is called alternate row piling, and I call it option A, method A, and in square. And the sequential row piling, so finish one row at a time, so that P1, I move to P3, and then I move to P5, and then I move the rig to P2, and then after P2 I do P4, and the last one I move to P6. So that we call it sequential row pile driving, alternative B. And the question become, does that matter with that sequence? In the next lesson, I will show you actually it matters. The work sequence will determine the duration of this work. But for now, I just give you some number to see, but next time we will check, next lesson we will check why. With that sequence, we have certain days of work. So that those are the two sequence. And that sequence will detect the relationship between the activity, as you can see there. So let's move on to the big picture that you see. So basically in this deck, the pier, we have three major work. The first one is pile. The second one, it will be the headers. And the last one, it will be deck slab. So with that one here, a big picture, that is, we need to find out the predecessor for each of the work. Predecessor is the activity that go before that activities. So in this case, by driving, that is the first activity you can do. So in that situation, you don't have any predecessor. You can start at any time. That's why we call non predecessor. Nothing have to be just like prerequisite in your class, right? Before you take this class, you have a prereq. In this case, the by driving, just like start class, intro class, like that, no prereq, so no predecessor. The headers, by driving have to be complete to do the headers, so that you can see the by driving is the predecessor or prereq in your class. So header here, the work in this case is preceded by bio driving. And then similarly, as you can see here, pipe 1, pipe 2 have to complete before we can be able to do the header. And then the next one is the to do the deck slab number 1, you need to have header 1 and header 2. So with that one, it means that the headers. And let me assume the duration for each work. And then we can be able to determine what is the time needed. So let's see work rate. In here, continue, complete with the work rate. Just like the daily output that you did in the problem 2. The work rate here, the pipe driving, I assume that is 1 day each. Work rate here, it finished in 1 day. 1 day per pile. And then pipe driving, let me assume 2 days. Headers, assume 2 days per header. And then the deck slab, I assume that need 5 days per deck slab. So that is work rate that you have. And now I suggest you to listen to this question and pause this video and think. How long will it take to complete this pier? If with that work rate, then how many days will this pier be completed? How many days this pier be completed? Pause, think, and get your answer before you continue to view this video. Is that good, everyone? So after you think about the number, and now play again, resume this video, and you will see that if it's 5 days per pile, it means that we have 6 pile in these scenarios, so it means 6 days. 5 days per header, we have 3 headers, so it will be 6 days. 2 times 3, 6. And deck slab, we have 2 deck slab. It means that 5 times 2 is 10 days. So as you can see, the total for pipe driving, it will be 6 days plus headers. 3 header for 2 days, another 6 days, so it's 12 days. And then 2 deck slab, 5 days each, so 10 days. So as you can see, it will be taking 22 days. 22 days. Make sense? And you say, oh, so why I have to study? Yes, that I can use the simple math to do. The question is that not easy. Actually, the 22 days, they don't need us as engineer to schedule. It's shorter than that. And that is the purpose of this scheduling, this sequence. So 22 days, basically the maximum that you can get, but you can do a shorter time. And that go to the detail relationship. And that's what I show it in here. The sequence, activity relationship in sequence. And preceded by, so now more detail. Instead of put an overall picture pipe driving, but we need to look at P1, P2, P3 until P6. Header 1, header 2, header 3, and then the deck slab S1 and deck slab S2. So what is preceding? And it depends on the two row piling alternative. B stands for sequential, and A square in square box, it stands for alternate row piling, as I shown you in this picture. So if we go to the sequential row pipeline, the first pi will be P1. So P1 have no predecessor. And then the next one, it will be P3. So P3, it will be after P1. If you look at the green line there, right? Sequential. And then P3, then the next one is P5 after P3. And then P2. So P2 after P5, etc. So this one, as you can see, for the sequential row pi driving, because we start at P1, so that it will be non-predecessor. P2, as I show you, that P2, in the green one, it follow P5. So P5 have to complete in that sequence, so that is P5, not P1, as you can see. And then P3, it's after P1, as you can see there, right, for the sequential. And then keep continue, P4 after P2, if you see that graph, and then P5 after P3, and P6 after P4. And now for the header number 1 with that sequence. Header number 1 is on. If I finish P1 and P2, I can do header number 1. So in this case, if I finish pi number 2, I can start header 1. So with that, the predecessor of header 1, it will be P2. Similarly, the predecessor of the header 2, it will be P4. As shown in here, P4. We need to do P4. And then we need to finish the header 1 as well before we move to header 2. Because we have limited resource, we cannot do simultaneously in this case. So we have header 1. And of course, keep continue. H3, we have it P6, and then it H2, header 2. And for the next lap 1, it will have header 2 after complete header 2. Then header 2 complete. Then we can put next lap. And then similarly for the next lap 2, we need to complete the header 3 and also the next lap number 1. So that is the first sequential. Now I suggest you to pause the video again and think about yourself and find the relationship for the alternate row pile in the red box A in there. Okay, so pause, and after you pause, you can see the solution here, alternate row pipeline. So it will be P1 start and then go to red P2, P4, P3, P5, and P6. So with that, P1 again, non-predecessor, and then go to P2, it will be predecessor P1. So again, it's same here, none. And then P2 now, it becomes P1, and P3, it's P4, P4, actually P2, P5, it will be P3, and then P6 equal to P5. And then similarly, header 1, I need to put it P2. This one, instead of P4, it's P3, and then header 1. And then we have P6 and header 2, it's the same. So one activity may have multiple predecessor. In this case, you have 2, but can have more as well. S2, and this one is S3 and S1. So that you can give the list of activities and then relationship. And of course, with that, you can use the software to do. But next time, in the next lesson, we will show you how to determine this. But let's go back to the example here. You see if I assume the work rate is 1 day per pile, 2 days per header, 5 days per next lap. And I told you earlier in this video, if we don't work into detail of the sequence, just finish PyDriving, and then put the header on, put the deck slab, then it takes 22 days. Now, if we plan this detail, if you go with the sequential row pipeline, the green one, and with the technique that we learned in next lesson, and I will go back to visit this as well. The sequential row PyDriving, the green one, it will take this whole peer complete in 18 days, 18 days. But if I use alternate row pipeline, the red one, it will take 16 days, 16 days. So we will get back to that. But as you can see, if we plan good plan, actually we can move from 22 days to 18 days and to 16 days. So that is amazing. And that's why we need planner. Everyone with me? So with that motivation, you can be able to solve the relationship for the project 2 and of course the real project with this concept in here. And before we start on that, you can practice yourself, identify the activities and establish the sequence of relationship for the activity in problem 2, and that here you can do on your own for this problem 2. What are the activities should be, and with that you can be able to see actually next lesson, the problem 2 in the next lesson, information given the predecessor, actually the solution for problem 4 in today's class. But before, I want you to practice that as well.